Thank you. One of the things I think is most interesting is that everything around us, every last bit of the stuff that's around us started as an idea. And the interesting part about new ideas is that they either evolve or they die. And if we're careful about how we evolve our ideas, they can blossom into useful, impactful designs that make a big difference in the world. What I'd like to do today is talk about our primary mechanism for evolving our ideas, and that mechanism is design. We all have the capacity to design, and we all do it all the time in different stages, at different times in our lives, to different degrees of success. But the big question in my mind is, will we put our capacity to design to work on the world's most pertinent problems? I've had the opportunity to study and practice one particular field of design for the last 15 years, and that field of design is engineering design. And I spent most of my industrial career working on things like this, designing components for the consumer electronics industry. And one of the interesting parts that we found in our study of engineering design and working on these kinds of products is that the influence of engineering design is all around us in our modern society. It's in our buildings, it's in our roads, it's in our cars, it's in our communication devices, it's in our medicine, it's in our clothes, it's everywhere. And one of the things that I started to do in the last 3 years was start to think about how the influence of engineering design can and should be felt by more people throughout the world. And this kind of area that I've been thinking about lately, we could think of it as an effort to try to understand how we could better design for the developing world. I've had the good fortune in the last 3 years to participate in 8 year-long engineering projects for the developing world. 7 of those were implemented to varying degrees of success on 2 foreign continents around the world. We had 28 engineering students involved, and 24 of them were able to travel with us to see the resulting design implemented in the setting that it was designed for. I want to tell you about some of the things that we learned. We learned some good things, we learned some bad things about how to evolve our ideas into ideas that would be useful for people in the developing world. But before I do that, I'd like to talk just basically about the design process. Whether it be for poetry, or whether it be for products, or whether it be for propulsion systems, the basic process of design is the same. And the fundamental elements of design are these. We first seek to understand the needs. We then create solutions that are aimed at meeting those needs. And then we evaluate how well those created solutions actually meet the needs. And at this point, we have kind of this embryonic idea. And then we get to look at it and we get to say, in what ways will it become better? And then we create those better versions of those ideas, and then we evaluate them, and we continue through this process again and again until what emerges is a design of value. Now, this idea of understanding and creating and evaluating is part of a larger study that a lot of people have worked on over a number of decades, which of course is the area of design thinking. So is it design thinking then that we need to better design for the developing world? Well, in part, yes, we do need more design thinking. But there are some things we learned about our successful projects and our failures. And there are a couple of things, 3 particular things, that we couldn't ignore, that really made the difference between our successes and our failures. And they were these. When we were people-centered in our work, we were successful. And when we were also interdisciplinary, we were successful. And when we were iterative in the way we went through the design process, we were successful. So let's talk about each of these for just a moment. To be people-centered, that means that people like me, engineers, we need to transition from being focused on technology and become more focused on how people's lives are impacted by that technology. And that's a subtle but important difference, and one that characterizes innovative products and services. So this doesn't mean that we throw away our expertise, but it does mean that we orient our expertise and we position ourselves professionally to make a difference in people's lives or to better society as a whole. Well, as we become more people-centered, we find that we also need to become more interdisciplinary. And the reason why we learn this is because we find out that our own disciplines don't hold all the keys to solving the world's most complex problems. Tim Brown, in his book, Change by Design, did a great job talking about interdisciplinary teams. And he made a distinction between multidisciplinary teams and interdisciplinary teams. And he said this, that multidisciplinary teams, you have individuals who become advocates for their own technical specialty. And what happens is the project turns into a negotiation. And what results is a great compromise. But interdisciplinary teams are different. They have collective ownership for the ideas, and they take collective ownership for the success of the project. Now, I've been on both kinds of teams, and I can tell you there's a kind of magic that exists in the interdisciplinary team. But not all teams will be interdisciplinary. And they won't be interdisciplinary because it takes a certain kind of individual. It takes a kind of individual with a willingness and a disposition to see beyond their own disciplines. That's exactly this kind of individual that's needed to solve the world's greatest challenges. Let me first describe why the world's problems requires this, and then I'll describe a couple of characteristics of interdisciplinary teams. At the turn of the century, the National Academy of Engineering established the 21st century's grand challenges in engineering, and 14 challenges were established. Make solar power economical. Provide energy by fusion, develop methods for carbon sequestration, manage the nitrogen cycle, provide access to clean water, restore and improve urban infrastructure, advance health informatics, engineer better medicines, reverse engineer the brain, prevent nuclear terror, secure cyberspace, enhance virtual reality, advance personalized learning, and engineer the tools of scientific discovery. One of the things that I think is so interesting about this list of challenges is that not one of them is going to be solved by a single disciplinary team. For this reason, the world needs us to be more interdisciplinary. So how do we become more interdisciplinary? Well, here are some characteristics of interdisciplinary teams. Interdisciplinary teams have intellectual maturity. And this is usually characterized by people being willing to work outside of their own disciplines. Teams that are interdisciplinary are often also small, and that they have the right blend of talent and resources. The small nature of these teams allows them to cross boundaries easily. And the third thing we find in interdisciplinary teams is that they rally around a common theme. Whatever that theme might be, the members of the interdisciplinary team must be willing to give up their own disciplinary interests for the interest of the common theme. And it takes this kind of dedication to have a truly interdisciplinary team. Another interesting thing about this cycle that we see in some individuals and some teams is that they take this cycle and they just do it once and they call it good and they turn this into a straight line activity. Frankly, this is no way to solve the world's complex problems, especially those described as grand challenges. Frankly, we won't arrive at the right answer on the first try. We just won't. It doesn't happen even to the best designers and engineers. So how do we become more iterative and avoid this straight line syndrome? Well, first, we come to appreciate the refinement that comes with iteration. And second, we plan for it. We put it into our schedule. We expect it. We welcome it. And we like to see the iteration happening. And the third thing, and equally important, is that we know when to stop the iteration process. So let me now describe one of our recent projects. And we'll see how these concepts of being people-centered, interdisciplinary, and iterative made a difference in the success. So about 1.5 years ago, WhoLives.org approached us about designing a machine, a human-powered machine that could drill holes into the earth 6 inches in diameter, 100 to 200 feet down to reach fresh drinking water in Africa. Well, under their sponsorship and with 8 months of work, we designed this machine. We went to Africa, Tanzania. We had a number of successful digs, and I'm happy to say that this particular picture here, now at this site, there's a working pump. And that pump's providing clean water, access to clean water, to a number of people in Magugu, Tanzania. So the engineering team worked through a number of challenging issues to get to this point. How do you cut the earth? How do you remove the cuttings? How do you spin the bit by human power alone? How do you add drill pipe sections as the bit gets deeper and deeper into the earth? And how do you support thousands of pounds of drill pipe when you need to retract it back out? Well, we worked through those problems, and we had successful digs here in America, and we felt like it was time for a field study. So we packed up the machine, sent it to Tanzania, and we followed closely behind. And when our aircraft was about to land in Tanzania, a shocking truth came to me and to others on our team, and that was that after 8 months of work on this machine, all we really knew how to do was put holes in the earth. And you know what? The grand challenge is not to put holes in the earth. It's to provide access to clean water. And it turns out that to provide access to clean water, you have to first know where to put the hole. And then you have to put a hole in the earth. And then once you put the hole in the earth, you have to case it so it doesn't cave in. And this casing also allows you to separate the rocks from the mud and the water. And then once you have that casing, you've got to have some kind of pump. And all of that needs to be maintained over time. And so the shocking reality for us was that our engineering work was only a small portion of what was needed to make a difference. And under the inspired leadership of John Renard at wholives.org, he somehow very quickly, and I don't know how he did this, expanded our team. He expanded it to the point that we had hydrologists. These are the people who tell us where we're going to find the water under the earth. We had the engineering team. We had the well casing team. We had the pump experts. But this was not all. John also managed to get venture capitalists involved and on site with us right there, business strategists, local politicians, local manufacturers, exercise scientists. This was a truly interdisciplinary team, and I can completely say that the success of this project was not because of our engineering, however good it might have been. It was actually because of the power that came from that interdisciplinary team. The single greatest factor that made it so easy for engineers to work with politicians or exercise scientists to be so excited about working with venture capitalists was that we rallied around a common theme. And that common theme was the people and their access to clean water. Design is iterative. The team knew that design would be iterative. And in its most embryonic state, this human-powered drill looked like this. It was a pipe with a bit, 2 guys walking around in a circle. But we knew that it would evolve, like all good ideas do. So the team planned for that. And the team used the process of iteration to take the idea to a point that would become useful. You can see the evolution of the design as we're going through this. And I just want to actually pause on this last to show you that these are the local manufacturers who are now producing this device. And I'm actually quite excited to say that in the first few months of this year alone, they've already produced 8 of these drills. So the world has some complex problems. And the interesting part is that we have the capacity to solve these problems when we take the principles of design and put them to work at evolving our ideas into useful, working, valuable, impactful solutions. It's not going to happen with just any old team. It's going to take an interdisciplinary team, one who's interdisciplinary in the design strategy. It's also going to take people who are people-centered in their themes. And it's also going to have to be that we iterate through our process. So back to the beginning. Ideas, they're all around us. We have them all the time. And they either evolve or they die. I know that our ideas can have impact when we become people-centered, when we become interdisciplinary, and when we refine through iteration. It may seem simple, but these things were the difference between our successful projects and our unsuccessful projects. Thank you.